Where is the South Pole?
It's a ceremonial place.
And where is it?
It's just 90 degrees south, so what's the problem?
Have you ever thought what latitude is? Sure, we all know latitude and longitude refer to a position on the surface of the Earth, and we are so used to them that we don't think about what latitude and longitude really are. Why the latitude of the poles are 90 degrees? Why is Paris at 49 degrees north or Punta Arenas, Chile at 53 degrees south? Even Gleason's map uses the same latitude than in the globe Earth. But it's wrong. Latitude is totally meaningless in a flat Earth. Let's go back to the basics. We have a space, and we want to describe the position of any object in that space, so we need a system of coordinates. The most basic one is the well-known Cartesian system of coordinates. We arbitrarily select one specific point that we can call the origin and three directions. The position is given by three numbers that give a distance in these three directions, x, y, z. But in certain situations, it is better to use a different system of coordinates. Take a sphere, like the Earth. We want to describe the position on the surface. The best choice is to put the origin at the center of the sphere. We could describe positions on the surface using the x, y, z coordinates, but if we want to follow a path on the surface, all the three coordinates will vary in a somehow confusing way, even for apparently simple paths. For this situation, it is more convenient to use what is called a system of spherical coordinates. You can describe a position using these other three numbers. The first one is the distance to the origin, also called the radius. All the points on a surface of a sphere are at the same distance to its center, so this coordinate is always constant if we want to refer to the surface. Thus, the position on the surface is then given only by the other two coordinates, longitude and latitude. Longitude is the angle of rotation around the line connecting the poles. Latitude is the angle between the position vector and the equatorial plane. Hence, when we say 90 degrees north, it means that there is a right angle between the position vector and the equatorial plane. And when we say 90 degrees south, then there is a right angle in the opposite direction between the position vector and the equatorial plane. That is the physical meaning of latitude. Take a flat Earth now. How would you describe a position on its surface? Well, if we put the origin at the center of the flat Earth, we can still use longitude as the angle between the position vector and some arbitrary diameter. No problem here. The problem comes with latitude. If you wanted to have the same values than in a sphere, what angle should it describe? A latitude of 90 degrees north is the center of the flat Earth. Can you draw any kind of right angle between the position and some arbitrary line going through the origin? What about 90 degrees south? What right angle can you draw to describe that position? It's impossible. And it's because you can't use a system of spherical coordinates in a flat Earth. You can have the same latitude in a flat Earth than in a globe Earth, because their geometry is totally different. But there's even more. Some flat earthers say the ice extends beyond the 90 degrees south. How would you refer to a land beyond 90 degrees south? What is 95 degrees south? What is 180 degrees south or 360 degrees south? The only meaningful system of coordinates in a flat Earth is what is called a polar system. Put the origin at the center of the flat Earth and describe the position using the distance to the center and the angle representing the longitude. Gleason's map uses the longitude but also the same latitude that we use in a globe Earth. It should use the radius instead.
Where is the South Pole?
It's just 90 degrees south, so what's the problem?
Certainly it is not at 90 degrees south, because latitude is totally meaningless in a flat Earth.